Assalamualaikum warahmatullahi wabarakatuh. I'm gonna discuss about the engineering mechanics, which is the engineering mechanics is one of the subject of industrial engineering department, and it is our meeting. Now I'm gonna show about the introduction to statics. So I'm gonna give you the overview of the mechanics. What is the overview of mechanics? And the second one is the basic concept of the mechanic. You have to know this, and then the last one we discuss about the scalars and factors. Okay, so we'll discuss about the three big ideas for today. Now we'll start from the mechanics. What is that? The mechanics. Mechanics is the physical science which addresses equilibrium and the motion of matter. So from this one you can see that they talk about the equilibrium and talk about the motion of matter. So mechanics is part of the physical science, right? But we have to know that mechanics, it's really a view. It's a view principle, but it has a wide application, especially in engineering. So we can use such as for the stability, for the strength of structures and machine, also using for the robotic and others. And after that, we can see this example. Yeah, the example Grace says that this is the sample of the mechanics. We will know about the equilibrium of the balancing of the board surface, so they don't gonna fall because they have many force. But they also have the force of gravitation. Here they have the force in the x direction. So we discuss like this one, but we only focus on the statics mechanics for this our meeting. And logically it will be separated into two parts. The first part, it is what we call as the statics. Statics is referred to the study of material at rest. So only study the material at rest, or it can it also mean that we concerned about the equilibrium of body. So it will tell the equilibrium of body under the action of force. And the second one is the dynamic. It's more complicated than static because we will discuss about the study of moving materials. So the moving material refers to the motion of bodies. So the body will get a force or an action, they will get a motion, so that we'll talk about the dynamics. Then after that we will discuss about the basic concept. Now I hope that you have to master this one first before you start to work with the static or the mechanic or the scalars and factors. The basic concept, first that is space. Space in this discussion, it will be referred to the geometric region occupied by the bodies. So it will mean that when the bodies occupy the position, and even the linear or angular measurement, that is the space. At the time, refer to the measure of the succession of event. That if you have many successions, so you have to complete the succession first, and you can measure the event of that. And the third one, the mass, is a measure of inertia of the body. So it is we can say maybe that is resistant to a change of velocity, because we can use the F equal to m times a, so it will be referred to the velocity, the change of velocity. And the fourth, it is the force action of one body on another. In this force, that it tend to move a body in a direction of its action. So if they have the force to the direction the right, so they will move, give the motion to the rigid body to the right. And if the direction of the force to the left will come to the left, so it will tend to the movement of the body. And the particle, it refers to the body of negligible dimension. So mathematically, we will going to say that the particle here is a very, very small number. It will be near to zero. So actually, it's negligible and the rigid body refers to the solid body in which deformation is zero or small, and it can be neglected also. So it's a rigid body, even though they have many internal force, such as a cable, they don't get any deformation. So deformation is near to zero, it's not really zero, but it's near to zero, so it can be neglected also. And then I will explain about the scalar and factors. The scalar and factors, that is separated into two kinds of quantities. The first is the scalars quantities, and the second one is the factor quantities. Scalar quantities are those which only a magnitude is associated. And the factors, it also have a direction. So if it have a direction, it also have a magnitude. And the scalar only has a magnitude that is associated to the quantities. For example, if I have a question that it is maybe your home, and I'm gonna ask you how far how the distance of your home to your college. Maybe you're gonna say 3 kilometers, but I can give you more questions. But 3 kilometers to the north, to the south, to the west, or to the east. So the distance is, if you need a magnitude and the directions, and plus the direction, so it's related to the factors. And if you only consist of a magnitude, it's related to the scalar. For example, for the scalar, we have a volume that is a part of scalar, speed, the energy, and the mass. Maybe you want different to distinguish between the velocity, because the velocity is the part of this one of the factors, but the speed is according to the scalar quantity. So if you want to say that when I'm riding my motorcycle, my speed is 40 kilometers per hour, so it's related to speed because you mentioned the scalar quantities. And if you want to say that if you want to show the factor quantities, you can say that my velocity is 40 kilometers per hour to the left, or to the north, or to the south, as well as they have to the direction together with the magnitude. I hope you can understand my explanation about this, because it's not as easy as that. And then come to the type of factors. We have 3 types of factors. The first is free factors, second one sliding factors, and third one is fixed factor. Free factors action is not confined to or associated with a unique line in space. So if you have a plate, for example, if you have a plate like this one, you can have the factor here, because they don't associate it to any unique line or any unique point. And the sliding factor, for the sliding factor, I'm going to give you an example here. For the sliding factor, we can say that the sliding factor is here. So if you have the factor here, it can move along to the sliding factor that have been determined before. So it's related to the unique line action, but it's not a unique point, so they can move along this linear line. And then the fixed factor, that if you have a really factor and they are stayed in a unique point, it's mean the fixed factor. So we really use most of them in our next explanation. Now we are coming to working with factors. Factors must obey the parallelogram, law of combination, or triangle law. And this combination also is called as the factor sum. So this is the equation V is equal to V1 plus V2. So this is the example of vector, right? This example of vector, it is the head of vector. It's related to the direction of the vectors. So if you have like this one, and it's a minus V, so actually if they have the same magnitude, so it will be the same value, but the differences between two factors of this only the direction. So it is plus revert to the right and the minus to the left one. So the distinguish both of to this only the direction of the factors. And then come back to the v sum, the factor sum, v equal to v1 plus v2. I'm going to give you an example like this one, that if you have two free factors, remember that it is the free factors, so you can revert to the parallelogram law. How to use the parallelogram law? Parallelogram law revert to the tail to tail, the tail of v1, v2, the tail of v1, like this one. You can take this one like this, and you'll get the sum of v, or the factor sum. So the v1 is the v2 is the factor sum. Is the parallelogram law, tail to tail, and the second one is the triangle law here, and the v2 here, v2. So this will be the v. So the correlation is head to tail, the head of v1 near to or close to the v2 tail of v2, so we will get a v factor or the factor sum. So remember that you have used the capital here, v capital, because the italic v, or we can, maybe I'm gonna write this one, it's revert to the unit factor. It's the scalar factor, is not the scalar unit, it's not a factor. And what if you have like this one? If you have like this one, v prime, the differences between like this one is or is the operation only the sign of plus, and the v1 v2 plus minus v1 v2. Remember that I have explained you about this. So actually, if you use like this one, you can use the, maybe you can, I'm going to give you the example of the parallelogram. The v1, you don't have any change of v1, but the v2 like this. And for the same way, you can use this. Yeah, you will get your v here. It is the v, the factor sum of v prime, sum. Factor component, it will be referred to if you have like this. Okay, for example, it's 10 on the second, it's 10 on the first. In the first line and the second line, and you have the v. It is the v2, it is the v1. Yeah, for example, you have to take this one and you get this one using the parallelogram, and it is the v. So v is, if I can say that the factor v2 here is the factor component of v in the line 2, and also, or maybe in the direction 2, and v1 is a vector component of v in the direction 1. Remember that it is the component. It also can express in a rectangular components, and in a rectangular component, which is in a rectangular component, we are usually use y and x, right? And if you have, this is the v y, and also here is the vx, and you will get the, so here is the v. So you can say that the vy is a component of v in the direction of y, and vx is a component of v in the direction x. I hope you can understand. And then also we will have a theta here. There's a theta here, you can calculate. So we can respect this one to the x-axis using the theta by using this equation. So the equation of theta, we can say, we can write this one is a tangent to the power of -1 Vy divided by the Vx. Please remember this equation to find the number of data. And then we are moved to the V, and because some vector V, they are expressed mathematically by multiplying its magnitude of V to the n. So sometimes V, remember that it is the V bold, V capital. Sometimes it is expressed mathematically by using this V in italic especially times to the factor by a factor of n, which is referred to the unit factor. It is the unit factor, so this can be used to also to find the factor. But you know that you have to remember, you have to know the unit factors, the number of unit factors, and it is very helpful if you want to solve some problems, such as in this case, in a three-dimensional V to Vn. Because of why, if you can refer to this picture, please focus on this picture here. Please focus here, and then I'm gonna break down this equation. So V, which will be to the, when it's direct to the x direction, it will be to Vx. So Vx is the component of V in the x directions times E, right? E revert to the n, the unit number. So if you have three directions, you have to break down this one to the three times. Vy equal to the G plus V Z equal to the K. But the problem is how you can get this number I, J, and K. The easiest way, you can use this angle of each theta. So for the, I will use this L, M, N to searching for this, and L, it will be the, like this, because it's the direction, the V of the direction to the X, so it will be the cos theta X. For the M, it will be the cos theta Y. And the N, it will be the cos of theta Z. Okay, so this will, it can be replaced to this one. It will be like this. Vx, it will be L times V. Vy, it will be M times V. And Vz will be M times V. Okay, that's enough. And actually, after we can calculate this one, we can come back to the main equation. That this equation, it will be to the Pythagorean equation. That the Pythagorean equation or theorem, it will be written like this: V squared equal to the Vx squared plus Vy squared and plus Vz squared. Or in another way, we can write this: V is the root of Vx squared plus Vy squared plus Vz squared. And that's all. That's our discussion for today, and I hope you can understand this one. If you have any difficulty, you found any difficulties, please discuss to your friend, or you can ask to me directly. Thank you very much, and that's all. Assalamualaikum warahmatullahi wabarakatuh.